complex numbers. In this example, we want to show that f of minus 2 equals 0, and hence data factors. So let's fill minus 2 into our function. So z cubed minus 6 times something squared, filling in our minus 2, using our calculator gives us 0. This then lets us know that z minus minus 2, which is equal to z plus 2, is a factor of the function. In part B, we now need to go on and solve. Well, to solve this, we're going to use the factor that we found previously. So at this point, we can say that z plus 2 times something is equal to the function. So 2 times what is 34? Must be positive 17. Z times something is z cubed, must be z squared. Meaning we don't quite know what the middle term is yet, so we'll just call that bz. Now, expanding some of this out, z times bz plus 2 times z squared gives us bz squared plus 2z squared. And that is comparable to minus 6z squared, so comparing coefficients. Cancelling through the z squareds leaves us with minus 6 is equal to b plus 2, so b is equal to minus 8, meaning we can rewrite that equation, z squared minus 8z plus 17. Now we know that z plus 2 equals 0, therefore z equals minus 2, as shown before, or the quadratic equals 0. Now to solve this quadratic, it doesn't factorise, so let's use the formula. Filling all our values in, taking care to fill them all in, which then leads through to the solution z is equal to 4 plus I, and also the conjugate z equals 4 minus I. So complex numbers will always come in conjugate pairs for solutions. Alternatively, instead of recognising those factors, we could have used long division. So here we can see, taking the original function, we know that z plus 2 divides into it as z equals minus 2 is a root. Therefore, that will give us some quadratic function. Okay, in this case, you can see the z squared and the 17, wanting to find the middle term. So let's go ahead and do this long division. Filling our values in, so we're going to divide z cubed minus 6z squared plus z plus 34 divided by z plus 2. Well, we need to multiply by z squared first of all. So z squared plus 2z squared. And then subtracting through gives us minus 8z squared. Next, we need to get rid of that 8z squared, so we'll multiply by minus 8z, which then gives us minus 8z squared minus 16z. Now, remember, of course, to bring that z down. Now, cancelling through that, subtracting, gives us z, take away minus 16, so positive 17z, bring down to 34. Multiply through by 17, and we have 17z plus 17 times 2 is 34. Subtracting that gives us nothing. And we can see here that the function can be written as z plus 2 as one factor, and the quadratic factor z squared minus 8z plus 17, which is what we found earlier. And then from there on, we could just use the quadratic formula to lead through to find the final answers. And that concludes the question.